So the nucleus of an atom, okay, the nuclei. Nucleus of an atom, we are familiar with the nucleus. The nucleus contains proton and neutron. Understood? Clear? So you know that the nucleus of an atom contains proton and neutron. These protons and neutrons are generally called nucleons. Proton and neutron are generally called nucleons. Okay, suppose this is the nucleus of a particular atom. So actually this nucleus contains 3 protons. So atomic number is actually the number of proton. The atomic number of the atom is actually the number of proton. Understood? Number of proton. So for example, this nucleus has 3 protons. So it is the atom having atomic number 3. Clear? This nucleus represents an atom having atomic number 3. It is lithium. If you are familiar with the periodic table, you can understand that. Hydrogen, helium, lithium. Yes. Atomic number 3 is lithium. So the atomic number written in the lower side. Okay. Atomic number, number of protons. Atomic number or number of protons is written in the lower side. Total number of nucleons. Total number of nucleons to be written in the upper side. That is total number of nucleon will be 4 plus 3 7. Clear? Understood? Okay. So understood. So lower number represents number of protons. The upper number represents total number of nucleons. Another example, a nucleon. This one is given. So this represents which atom? This represents nucleus of which atom? Here the number of proton is 2. Correct? Number of proton is 2. So helium. Understood? Clear? Hello. Helium number of proton is nothing but it is atomic number. Atomic number is 2. It is helium.
Yes, sir.
Number of proton to be written in the lower side. Number of proton to be written in the lower side. Total number of nucleons, 3, to be written in the upper side. Clear?
Yes, sir.
So in general, X is an element. X is an element like helium, lithium, something like that. X is an element. Its atomic number is denoted by Z, or number of protons. Number of protons denoted by Z. And total number of nucleons. Atomic mass. It is also said to be atomic mass. Written in the upper side. This representation you have to understand. The lower number is number of proton denoted by Z. The upper number is total number of nucleons, also called atomic mass, A. So Z represents number of protons. A represents atomic mass or total number of nucleons. Clear?
Yes, sir.
I have already sent the PDF, so no need to write it. It is actually a quick recap. And remember, A minus Z, upper number minus lower number represents neutron. Okay? Upper number minus lower number, A minus Z, represents number of neutron. Clear?
Yes, sir.
Please note that the lower number is proton. If a symbol is given like this, the lower number is proton. The difference is neutron. Understood?
Yes, sir.
And okay, you please read all these things if you are okay. Isotopes of hydrogen. So how can you understand it is isotopes? Because it's isotope of hydrogen because the lower number is same. Understood? Hello.
sir.
If the lower number is same, it's isotope. Clear? If the only lower numbers are same, it is isotopes. So a lower number means proton or atomic number. So same element, we write the same element in both cases. We write the same symbol, same chemical symbol we use. So the two elements are said to be isotopes if the lower numbers are equal. Understood?
Yes, sir.
Protons, lower number means protons. Number of protons equal. Other things, other numbers will be different. Only number of protons same. Are you okay?
Yes, sir.
Isobar. So remember, isotope, the lower numbers, only lower number same. Think like that. Only lower numbers same. Then isobars. Same atomic mass. Atomic mass only equal. Only atomic mass are equal. For example, look at these two. S13 and helium-23. How can I say that they are isobar? In the case of isobar, the upper numbers are equal. Understood? Hello? Hello? Only the yes. Only the upper numbers are equal. Only upper numbers are equal. Or atomic mass. The upper number is also called atomic mass. So isotope and isobar, memorize like that. Like this, if the lower numbers are equal. Is it audible? If the lower numbers are equal,
Yes, sir.
if only lower numbers are equal, isotope. If only upper numbers are equal, isobar. Okay? Clear?
Sir.
And isotones. Isotones means same number of neutrons. I mean, in the case of isotones, the difference will be equal. Number of neutron is actually the difference. Understood? Correct?
Yes, sir.
Here the difference is 2 minus 1. 2 minus 1 is 1. Here the difference is also 1. 3 minus 2, 1. So isotone means the differences will be equal. Or number of neutrons will be equal. Clear? You please read it. Next is atomic mass unit. This is the next topic, atomic mass unit. So atomic mass unit. So it is a unit representing weight of a body, weight of a nucleus, mass of a nucleus. It is a unit for measuring the mass of a nucleus. We don't prefer kilogram for the measuring a small, extremely small things like nucleus. Understood? Clear? The nucleus is extremely small. The unit kilogram or gram is not suitable for that. So we use another unit for measuring the mass of the nucleus. So one atomic mass unit definition. One atomic mass unit is the one atomic mass unit is defined as 1/12th of the mass of the carbon atom. 12C means 12C6. Okay, 12C6. The lower number means proton, upper number means total number of nucleon. So 12C is the short form. 12C is the short form, meaning that 12C6. So one atomic mass unit is 1/12th of the mass of carbon 12 atom. Okay.
Yes, sir.
Okay. Carbon 12 atom will have some mass, right? Carbon 12 atom will have certain mass. 1/12th of its mass. 1 by 12th of carbon 12 atom represents 1 atomic mass unit. Okay, so 1 atomic mass unit, the value you have to memorize. 1 atomic mass unit is 1 by 12th of the mass of carbon 12 atom. So 1 atomic mass unit, please memorize the value 1.660539. You need to memorize the value. I mean at least 2 digits after point you have to memorize. At least 2 digits after decimal you have to memorize. 1.66 at least. 1.66 into 10 raised to minus 27 kilogram is the mass, atomic mass unit. Okay. Hello.
Yes.
So you please read it, and if you have any doubt you please ask right now. Taking too much time. Are you reading? Have you understood? Hello.
Yes, sir. Yes, done, sir.
You are not responding. You are taking too much time for this. You understood, or shall I repeat anything?
No, sir, I understood, sir.
You understood.
Net is nowadays, yes.
Okay. Actually, I am recording parallelly. So after the class, you may you may go through the video any number of time. Okay. You can take forward or backward. No problem with that. So the next is size of the nucleus. I have already written everything. I don't want to delete it. Let whatever I have written here, let it be there. I don't want to delete it. Let me explain about the size of the nucleus. This formula, there are so many questions based on size of the nucleus. The nucleus look like a sphere. Understood? Nucleus of an atom look like a sphere. Hence it has a radius. Since the nucleus look like a sphere, it has a radius r. The size of the nucleus depends on atomic mass. Atomic mass means number of elements inside the nucleus. Number of nucleons, total number of nucleons is said to be atomic mass. So the radius of the nucleus depends on atomic mass. The formula is R equal to R0 into A raised to 1 by 3. This formula is very important one. Radius of a nucleus is given by the formula. Radius of a nucleus is given by the formula R equal to R0 into A raised to 1 by 3, where R0 is a constant. R0 is a constant 1.2 into 10 raised to minus 15 meter. 1.2 into 10 raised to minus 15 meter. This formula you have to memorize. A stands for number of elements inside the nucleus, or total number of nucleons inside the nucleus. That is A. Okay, so you please read it. Are you okay? Size of the nucleus, this formula is okay. R equal to R0 into A raised to 1 by 3. Clear?
Yes.
Then mass energy relation. So when I explain a new topic, don't forget the all other things. the size of the nucleus is required. There are problems based on this. Okay, the next is about mass energy relation. Energy and mass are related to each other. Mass is another format of energy, or energy is another format of mass. Mass can be converted to energy. Clear? The mass can be converted to energy. Energy is equal to mc square. Let us learn without any proof. Energy is equal to mc square. So m mass will have some energy. Clear? M mass, the energy corresponding to the mass m is given by, energy corresponding to the mass m is given by E equal to mc square. M is the mass in kilogram, C equal to 3 into 10 raised to 8, E is the energy in joules. So if you are given mass, you can find the corresponding energy using this formula. This one is okay. E equal to mc square is okay. Clear? And we have studied that one atomic mass unit as 1.66 into 10 raised to minus 27 kilogram. We have already studied. One atomic mass unit is approximately mass of a single proton. Approximately. I am saying approximately. One atomic mass unit is what? It is actually approximately mass of a single proton or mass of a single neutron. Understood? Clear? General definition is what? One atomic mass unit is 1 by 12 times carbon 12 atom. But approximately what we can say? Approximately one atomic mass unit is mass of a single proton or mass of a single neutron. Both are approximately equal. So one atomic mass unit is 1.66 into 10 raised to minus 27 kilogram. If you convert a single proton, I told you that every mass can be converted to energy. Every mass can be converted to energy. So if you convert a single proton or single neutron into energy, that is one atomic mass unit. If you convert one single proton or one single neutron is converted to energy, how much energy you will get? You will get 931.5 mega electron volt. This much energy you will get. So one atomic mass unit, approximately one proton or one neutron, if you convert a single proton or a single neutron into energy, you will get this much energy, 931.5 mega electron volt. Okay, clear? Hello?
Yes, sir.
Electron volt is a unit of energy. Electron volt is a unit of energy. 1 electron volt is 1.6 into 10 raised to minus 19 joules. If you want to convert it to joules format, use this formula. 1 electron volt is 1.6 into 10 raised to minus 19 joules. And this mega, mega stands for 10 raised to 6. Mega means into 10 raised to 6. Then nuclear binding energy. Okay, nuclear binding energy. There are certain theories you have to keep in your mind. Nuclear binding energy. Its definition is very simple. Energy by which all the nucleons in the nucleus are bound together. Look at this. If you look at the nucleus, there are protons and neutrons inside that. Clear? There are plenty of proton and neutron inside a single nucleus. They are bound to each other. They are bound to one another with a strong force. Each of the nucleons are attracted to one another with a very strong force, so that it is extremely difficult to separate them. It is extremely difficult to separate the nucleons out of the nucleus, because all the nucleons are bound together with an extremely huge force. Clear? Understood? Hello?
Yes, sir.
So the energy by which all the nucleons are bound together is binding energy. Clear? All the nucleons are bound together with some energy. That energy is called nuclear binding energy. So nuclear binding energy is clear. Understood?
Yes, sir.
Nuclear binding energy is clear. Now the another thing is binding energy per nucleon. Binding energy per nucleon. It's very simple. Binding energy per nucleon means it is the energy by which a single nucleon is bound by the other nucleon. Binding energy per nucleon means it is the energy, it is the energy by which a single nucleon bound by the other nucleon. Or in simple language, binding energy per nucleon is the energy required to separate a single nucleon. I think the second definition is much easier to understand. Binding energy per nucleon is what? Binding energy per nucleon is what? It is the energy required to separate a single nucleon. Understood?
Yes, sir.
So total binding energy means what? Total binding energy means it is the total energy required to separate all the nucleon. Nuclear binding energy can be defined in this way. Nuclear binding energy can be defined as the total energy required to separate all the nucleons. But binding energy per nucleon, it is the energy required to separate a single nucleon. Clear? Hello? So energy required to separate a single nucleon is said to be binding energy per nucleon, EBN. Binding energy per nucleon is equal to total binding energy divided by A. Total binding energy means it is the energy required to separate all. EB means energy required to separate everything. So that is the binding energy. So binding energy divided by atomic mass is binding energy per nucleon. Okay? Clear? This formula is very, very important. Now, binding energy understood. I explained some 3 or 4 times. I don't want to explain again. You may watch the recorded video. I think it is better. Okay, so binding energy you understood. So the formula for finding binding energy. Formula for finding binding energy. That formula is very, very important. Before explaining the formula, let me explain some important terms, important letters. Binding energy, to find out binding energy, first of all you will be given the element. The number of proton is Z. Clear? The lower number is what? The number of proton denoted by Z. And the upper number is total number of nucleons. Lower number is proton and the difference is A minus Z. The difference is neutron. This part is clear?
Yes, sir.
So if an element is given like this, the lower number represents number of proton and the difference A minus Z represents number of neutrons. Let MP and Mn represents mass of a single proton and a single neutron respectively. Please note the symbol. MP and Mn are what? MP and Mn represents mass of a single proton and a single neutron respectively. Okay? Clear?
Yes,
the binding energy. To find the binding energy, there are two steps. To find out the binding energy, we need two steps. The first step is you have to find out mass defect. The derivation I will not discuss. To find out binding energy, the step 1 will be always this: mass defect, delta M. Mass defect is ZMP. Derivation I will not discuss. ZMP plus A minus ZMN. You have to memorize the formula. No other option. ZMP plus A minus ZMN minus mass of the entire nucleus. The given nucleus will have a certain mass, that is m of x. M of x means mass of the given nucleus. ZMP plus A minus ZMN minus mass of the given nucleus. This is said to be mass defect. Okay, clear?
Yes, sir.
So delta M is the first step. To find out the binding energy, the first step will be delta M, mass defect. You must memorize this formula. No other option. Memorize this formula. After finding the mass defect delta M, now we can find out the binding energy in two ways. There are two methods available for binding energy. Case 1, if delta M is in kilogram. After finding delta M, suppose everything is given in kilogram. Everything is given in kilogram. The delta M will be in kilogram. If delta M is in kilogram, the binding energy will be delta M into C square joules. Memorize that formula without any proof. If delta M is in kilogram, binding energy equal to delta M into C square joules. Memorize that. And if delta M is in atomic mass unit, there are two cases. If delta M is in what? Atomic mass unit, then binding energy is given by delta M into 931.55 mega electron volts. So please remember this formula. Okay, you completed, right? Finished? Okay. Let me discuss one question. The solutions are written here. I don't want to delete. Obtain the binding energy of the nuclei iron and bismuth in units of mega electron volt from the following data. Okay. Hello.
Yes, sir.
You understood the binding energy? You still remember that binding energy?
Yes, sir.
Okay. Binding energy, the name itself, if you read the word binding energy, you can understand the meaning. Binding energy. At what energy bound together? So, I am going to find out the binding energy of Fe 2656. First step is mass defect. To find out the binding energy of a nucleus, the first step will be mass defect, delta M. That formula I told you, you need to memorize that formula. Z into MP plus A minus ZMN minus mass of the given nucleus. This formula I have already explained. Is it same thing for bismuth? Other one also. This one also same method. The binding energy is a very important question. It is a sure question, binding energy. To find out binding energy of bismuth, Bi, bismuth 83209, we have to find out the binding energy. The first step for binding energy is delta M, mass defect. In all the questions, binding energy, the first step will be delta M, no deviation from that. So you have to first write the delta M, mass defect. Write the formula. You have to memorize that formula. ZMP, must memorize. ZMP plus A minus ZMN minus mass of the given nucleus. Mass of the given nucleus. And if the element is given, initially you may write the values of Z. Z is the lower number. Z is what? The lower number, 83. and A is the upper number. A is 209. So Z value and A value you have to write it first. Is that okay? Clear? Z value and A value. Are you okay?
Yes, sir.
So delta M you must memorize. ZMP plus A minus ZMN minus mass of the given nucleus. Z is 83. MP will be given. MP and Mn will be given in the question. So ZMP will be 83 into 1.0078. MP will be given in the problem. Plus A minus Z. A minus Z will be 209 minus 83. A minus Z is what? 209 minus 83. Into Mn. Into Mn. Minus mass of the bismuth. Mass of the bismuth nucleus is given in the problem. Mass of the bismuth nucleus is given in the problem. Write it. Everything is in atomic mass unit. After doing the calculation, you will get 1.7608 U. 1.7608 atomic mass unit. So the atomic mass unit into 931.5 mega electron volt will be the binding energy. Atomic mass unit into 931.5 mega electron volt will be the binding energy. So 1640.26 mega electron volt will be the binding energy of bismuth nucleus. Okay.